The last lesson in Unit 2 is the lesson Justification and Proof. The purpose of this lesson is to give students practice in writing formal proofs to show that conjectures are true. If you recall in the previous lesson, Claims and Conjectures, we discovered some conjectures that we felt were true. The specific theorems being examined in this task are: vertical angles are congruent, the measure of an exterior angle of a triangle is the sum of the two remote interior angles. When a transversal crosses parallel lines, alternate interior angles are congruent, corresponding angles are congruent, and same-side interior angles are supplementary, or they add to 180 degrees. A vocabulary word you want to add to your math notebook is the converse of a statement. The converse of an if-then statement is one in which the conclusion and the given have been switched. So for example, if I say, if today is Friday, then tomorrow is Saturday. The converse of this statement is, if tomorrow is Saturday, then today is Friday. So in the first task, we were given that line AC and line BD intersect at point E, and we were asked to prove the angle AEB is congruent to angle CED. So what we have to do is use our knowledge, our geometry knowledge, and what we know based on this diagram. So the first thing we said in paragraph form was that angle AEB and angle BEC form a linear pair. So AEB and BEC form a linear pair. If you recall from our previous lessons, that means that they add to a sum of 180 degrees. We also said that angle BEC plus angle CED also form a linear pair, so they also will add to 180 degrees, and I've marked those two angles in blue. So if you recall, both of these angles share the measure of angle BEC. So what we did next was we wrote out that the measure of AEB plus the measure of angle BEC equals the measure of angle BEC plus the measure of angle CED. We can do that because we know both of the angles together add to 180. So by the transitive property of equality, or we could also use substitution, we'll substitute in where we see the 180 degrees, we can say that that is true. If we were to subtract the measure of angle BEC from both sides mathematically, we would see that we are left with the measure of angle AEB equal to the measure of angle CED. Therefore, we can conclude that those two angles will be congruent. To write that in two-column proof form, I have done so here, so you can take a look at the two-column proof form, and you may pause this video so you can copy this down in your notes. The next proof that we looked at was the proof of the exterior angle of the triangle. In this case, it would be angle 4, would be equal to the sum of the two interior angles. So if you recall from the last lesson, we did make the conjecture or educated guess that the measure of angle 1 plus the measure of angle 2 would be equal to the measure of angle 4. And in this example, we are trying to prove that to be true. So when we wrote out our formal proof, we wrote all our information there. I'm going to go down to the two-column proof instead of that first one. So angle 4 is an exterior angle of a triangle. We were given that information. We know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So I'm going to scroll back up to the diagram. So the measure of 1 plus 2 plus 3 equals 180 degrees. We know that because we've already concluded in this unit that the sum of the three angles in a triangle add to 180 degrees. So we wrote our reason as the triangle sum theorem, but you also may write that out in words. For the third statement, the measure of angle 3 plus the measure of angle 4 adds to 180. We can see that here because 3 plus 4, the measure of angle 3 plus the measure of angle 4, lie on the same line. Therefore, their sum is 180 degrees. So we said definition of linear pairs. In our fourth statement, we said that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 should then equal the measure of angle 3 plus the measure of angle 4 because of the fact that both of my angles in 2 and 3 add to 180. So by substitution, or the transitive property of equality, we can say that those are equal. If we subtract the measure of angle 3 from both sides of that equal sign, we are left with the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And that the reason we can say that is because of the subtraction property, and we have just proven that the angle 1 plus angle 2 will be equal to angle 4. The last proof that I am going to discuss, although there are a few more from your notes, I am not covering number 3, and I'm skipping to number 4, and you'll want to take a look at the Canvas video for numbers 5 and 6. But on number 4, we are asked to prove that the alternate interior angles, angles 3 and angle 6, are congruent. So in paragraph form, since we know that line BF is parallel to line AD, I've marked them parallel. We mark parallelism by putting arrows on the lines. We know then that angle 1 and angle 5 are congruent. Now, how do we know that? From our previous lesson, where we saw that corresponding angles are always congruent. The measure of angle 1 and the measure of angle 3 form a linear pair. That means that they add up to 180 degrees. By substitution then, we can say that the measure of angle 5 plus the measure of angle 3 equals 180 degrees. Likewise, we can say that angle 5 and angle 6 form a linear pair. That means that they add to 180 degrees. By substitution, we can then say that the measure of angle 6 plus the measure of angle 5 is equal to 180. By the transitive property or substitution, we can set those both equal to each other. The measure of angle 5 plus the measure of angle 3 should be equal to the measure of angle 5 plus the measure of angle 6. If we subtract the measure of angle 5 from both sides, we will be left with the measure of angle 3 is equal to the measure of angle 6. And if I go up to my diagram and I mark which angles those are, angle 3 and angle 6, therefore we can conclude that they are congruent and they are alternate interior angles. If you need more help on this lesson or the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.